Hello friends, I am Anurag and today in this video we will talk about nanotechnology and nature. Friends, nature is the most powerful thing in this universe. Someone can doubt on the God, but we cannot doubt on the nature because nature exists in front of us. And nature gives us a lot. It gives us the food, it gives us the water, it gives us the air, it gives us the medicine. So we are totally blessed with the nature. And to explore the nature, that is the job of the science. Whatever occurs in this universe, so science job is that we have to give the explanation on the basis of the logic and we have to explore the nature. This is the job of the science. Friends, nanotechnology is also being grown by learning through the nature, and because in the nature there are so many things, so we can see those things and we can understand that how we can make the similar kind of the things artificially. So that was the starting of the nanotechnology. But in the starting, the nanotechnology that exists starting since the inception of the nature, but we don't have any instrument by that we could see the nano objects. So once we got the scanning tunneling microscopy in 1982, then we were able to see the nano size of the object. Then a lot of development started in the field of nanotechnology, and with using these electron microscopy and scanning tunneling microscopy, people started to observe the natural made materials like the plants leaves. They have started that what kind of structures they have. So once they have seen these materials at the nanometric level with help of the electron microscope, then we have seen a very beautiful structures inside these materials, and because of that these materials have the unique properties. So these unique properties are being shown by these materials with help of these with these materials, because of what is the region that is being explored under the nanotechnology. So in this video we will discuss about some of the basics of nanotechnology. Then we will see and discuss some of the natural materials or the creatures of the nature that has very unique properties. So we will understand that why these materials or these nature creatures have these unique properties on the grounds of the nanotechnology. So firstly, we will start that what is nanotechnology. So friends, nanotechnology, this is the technology that deals the atoms and molecules, means any structure, any material, any device that have at least one of the dimension at the nanometric level. Nanometric level means up to the 100 nanometer, then they are considered as part of the nanotechnology. So then the question arises, why we discuss the nanotechnology? Because once we come to that much length of the scales, means at the atomic level and molecular level, then the properties of the materials, they are drastically changed. So because of that, the nanotechnology is very interesting, very popular, and lot of interesting phenomena and properties are being obtained once we synthesize the materials at the nanometric level or at the atomic and molecular level. So basically in the nanotechnology, we manipulate atoms and molecules, we change the structure of the material, size of the particle, shape of the particles, and by that changing, these materials have the unique properties. So firstly, now we understand that what is the meaning of nano. So nano and how much is the 1 nanometer. So 1 nanometer length scale is 10 to the power minus 9 meter. So we know that the atom's diameter that generally lie 1 to 2 angstrom. So in a 1 nanometer of the particle, there are almost 4 to 5 number of the atoms. Similarly, suppose we have a 100 nanometer of particle, it means it have almost 400 to 500 number of the atoms. So the size of number of the atoms, so size of the particle, it is being decided that how many number of atoms are there in this particle. Accordingly, their size got decided. Friends, this is a very smaller length of the scale. You see that 1 nanometer, the thickness of the human hair, that is 80,000 times greater than to the 1 nanometer size of the particles. And even the red blood cells, they are approximately 7,000 nanometer wide as compared to the 1 nanometer. So naturally, this is a very small length of the scale. We cannot deal atoms and molecules by the hands. We cannot see atom and molecules by our naked eyes. So a very special technology is required, a special instruments are required. By that way, we could manipulate atoms and molecules, and we could change the properties of materials as per our requirement. So the nanoparticles, they may be of the different shape. They may be in spherical shape, they may be cubical shape, they may be rod shape, they may be the fiber shape. So shape means that is the morphology, means what is the shape of the material. So there are two things. One is the size of the particle, and second is the shape, that what kind of the shape the particles have. So the size of the particle is being decided that how many number of atoms attach to each other, and they make a size of the particle. And the shape is decided that how these particles are attaching to each other. Either they are attaching in all three directions, so then they may have a spherical shape, cubic shape. If their attachment is like this, that they are growing only in one dimension. In two dimensions, their growth is restricted. Only they are growing only in one direction. So then they will get that is a nanowire shape, rod shape, fiber shape. So that is depend upon, ultimately it depend upon what is the condition of your synthesis, what is temperature, what is environment, and what are the pressure. So what are these conditions? They will decide that how many atoms will attach to each other and in which direction they will grow. So accordingly, the shape and size of the particle is decided. So friends, as the shape and size of the particle change, then the property of materials change. A same material that could give you the different properties once you change the size and shape. So there will be change in the property. That is the basic theme of the nanotechnology, that we will reduce the size, we will change the size and shape, then we will get change into the property. But this change in the size must be at the level of nanometric or atomic level. Then only we see the drastic change in the properties. Now we come to that, what are the factors because of that the properties of the material got changed once we come to the nanometric or atomic and molecular level length of the scale. So there are two major reasons for that. However, there are some other effects also, but majorly we consider the two reasons. One is the increased relative surface area, that if we reduce the size of the particle, then the surface area increases. That we can understand with this formula, that surface density, that is depend upon the density of material as well as to the diameter of the particle. So surface density is inversely proportional to the diameter of the particle. So if we decrease the size of the particle, then surface density increases. So for example, if the size of the particle is 10 to the power 6 meter, that is at the micron level, then the surface density for a particular material whose density is 3 into 10 to the power 6 gram per meter cube, it is 2. But if we reduce the particle size up to 1 nanometer, means 10 to the power minus 9 meter, then the surface density is the 2000. So it is enormously the surface area change. You could also see if the particle size is 30 nanometer, then only 5% of particle that will be at the surface. And if it is the 3 nanometer, then the 50% particle that will be on the surface of the matter. So what happens once there are a lot of atoms will be on the surface, so they have the dangle bonds. Broken bonds are there, and these atoms have the free bonds. They are free to make bonding with some other molecules. So because of that, the chemical activity of these materials increases very enormously by increasing the surface area through reducing the size of the material. So one thing is that surface area increases once we reduce the size of the particle. And second is the dominance of quantum effect. Once we come to the atomic and molecular level, then the rule of games change. Means if we are dealing the bigger bodies, celestial bodies, so then we apply the Newton's law for their movement, how much will be velocity after time t, what will be energy and all that. So then that is the classical rules will apply. But if we have to know that what is the velocity, distance, and these we are dealing the atoms and molecules, so we cannot apply the classical physics. We have to apply the quantum physics. And you know that quantum physics is that that explain the quantization of energy. That energy is not continuous, it is quantized. And because of that, the density of state got changed, band gap of the material got changed, and the property of materials got changed. So because of that, electrical property, band gap will change, it will result change into the electrical properties. Mechanical properties got changed because there is a changing of the bonding, there is a changing of the grain boundaries. So because of that, mechanical property, optical properties, magnetic properties, electrochemical properties, so they all got changed once we come to the atomic and molecular levels. So because of the dominance of the quantum effect. So these are the two major factors for changing the property of materials once we come to the nanometric or smaller length of the scale. So now we have to come and we will discuss some of the natural materials, and they show very unique property. Friends, you have seen the lotus leaf. Lotus leaf is special because it is having a very unique property that water does not stick over the lotus leaf. It is having the water repelling property. So what is the reason for that? We only simply say, before the nanotechnology, we say that it is because of the contact angle. Because if in a material, if the contact angle is less than to the 90 degree, then it is a hydrophilic. If it is greater than to the 90 degree, it will be hydrophobic. So this lotus leaf contact angle is very large. It is around 170 degree. So because of that, it is hydrophobic. It repels the water. But we have no answer that why the contact angle of this lotus leaf is too large, 170 degree. Because of that, it is having the hydrophobic property. So we have no answer on that ground. We only know that this water leaf, this lotus leaf, so the hydrophobic property because of the contact angle is greater than to the 90, it is 170 degree. But we don't know that why the contact angle is too large for this lotus leaf. So that answer comes by the nanotechnology. Once we have analyzed the lotus leaf structure with help of scanning, tunneling microscopy or any other electron microscopy, by that we could see the nano size of the objects. So then we have found that there are a very special kind of the structures over the surface of the lotus leaf. That is the scanning electron microscope image of a lotus leaf. So we have seen that there are very, very refined nanostructures are there, and these nanostructures are playing the role because of having a very, very large contact angle for this lotus leaf, and due to this, it has the water repelling property. So we could only know this once we got the any microscope, so that we could see the structure of this of this lotus leaf. So thing is that we get the development in the field of nanotechnology only once we were able to see the nano object with help of the electron microscopy. So after that, the scientists had made the similar kind of the structures artificially of some material, and they have found that that artificially made material also showing the hydrophobic property as similar to the natural lotus leaf. So we have learned this, and we have made this kind of artificial material by learning from the natural lotus leaf. So that is the close association of nanotechnology with the nature, and this nanotechnology is basically grown and developed by learning through the nature. We also have some other examples, that these are the pictures of the geckos. So gecko feeds pictures are there over this slide. So geckos is what? So geckos are basically, you know that they have some special properties, special things. One thing is that they can run on the inverted and vertical surfaces. They also can move on the rough surfaces, smooth surfaces. And even though once they move, they know that which surface is rough and which surface is this is vertical or this is the inverted. So accordingly, they just control the movement of yourself, of yourself. So because of that, what their tools are, they are working like a pressure sensor. And another thing is that their tools does not degrade. They don't degrade with the time, and even no dust, no oil, etc. stick on their feet. They are always cleaned. So self-cleaning tools are there with the geckos. So it's again, once it is being analyzed, their feet, but there are tools with the help of the electron microscopy. Then it has been found that they have a very, very beautiful nanostructures. So that kind of the nanostructures are being found, and then the technologists, they have made similar artificial structures, and they also found that kind of the self-cleaning properties on the artificial made materials. Similarly, the water striders, they once they move on the water, they walk on the water, they don't get wetty, their feet don't get wetty. So there are many regions for that. Surface area, that is their gravitational force, surface forces, but their surface on their legs is also the hydrophobic. That is also being found by analyzing the feet of these striders. So they also have the nanostructures. Similarly, the different beetles, flies, they all have the nanostructures, and because of that, they have the capability to stick on the ceilings and on the walls, and they can move on the any kind of the inverted or vertical surfaces. Similarly, that you have seen the butterflies. So butterflies, they have the different colors. So they may be of the different colors. So the region of the different color in the butterfly, that is because of the scattering of light. So light got scattered, accordingly that there will be change into the color. And because the structure over the wings of the butterfly, that is of the nanometric size, and that is the less than to the wavelength of the optical light, means less than to the 400 nanometer. So because of this scattering phenomena, they have the different colors. So that is being seen by this picture, that this is the ACM image of a butterfly wing. So you can see that there are very beautiful nanostructures of the 200 nanometer of the size of this, even smaller to that. So this is again that these special structures make a change scattering, and because of that they show the different colors on the wings of these butterflies. Friends, this is a picture of a natural flower. So it is very beautiful, you can see, and how symmetrical there are the growth of this flower. So these are natural things, they are grown naturally. We have grown these structures naturally. So the job of the nanotechnologist, material scientist, that is that how we can make similar kind of the structures with the artificial inorganic organic materials, and so that we could have some unique property that could be utilized for the application and welfare of the humanity. So friends, these are some of the artificially made structures that they are being made by the nanotechnologist or material scientist. So these are the nanowires, they are aligned nanowires. These are the nanoballs of these different things. These are the porous materials, they are being fabricated by the process of lithography and etching process. So different materials, they are different morphology of the nanoballs, nanoflowers, nano sheets. So different kind of the shapes is being made. So that is all these things that has to be controlled by the synthesis route, that how you are making the material, how you can restrict the growth in a particular direction so that you can get a required structure of the material, a morphology of the material. So that all has to be controlled with during the synthesis and their parameters. So we can make the different kind of these structures, and then they have the unique property. Same material, suppose it is the one material, suppose it is zinc oxide. If you grow in different forms, that is in form of the nanowire, if you grow in the nanoflower, if you grow in some other morphology, so then there will be a different property. Your band gap will be different, it will vary by changing the size. So that is the beauty of nanotechnology, that we can tailor the property of materials by controlling their shape and the size. So in this video, we have learned that how nanotechnology grow by learning through the nature, and the similar kind of the materials, the replica of the natural materials are made by the nanotechnologist or material scientist, and those replica of artificially grown having the similar property as being shown by the natural materials. So a lot of development is going on in this field of nanotechnology. People are making the natural skin, natural bones. So that is all because of the nature. We are learning from the nature. So the job of science is that we have to analyze the things in the nature, and then we have to think that how we can give the explanation of the nature for the event that is occurring in the universe, or how that kind of the similar materials we can grow. So friends, I hope that you have enhanced your skill by this video in field of the nanotechnology. So thank you for watching this video.